Well, greetings everyone. This is David Gauci. Dave Nagel and I welcome you to the second in the Business and Energy Talk series of Forum 2100. Forum 2100 is an initiative to promote constructive dialogue on business opportunities in the energy domain. Today, it is our pleasure to feature Francois Vuille, Executive Director of the Energy Center at École Polytechnique Fédérale de Lausanne, EPFL, in Lausanne, Switzerland. An astrophysicist by education, Francois has had an interesting and an extensive career in the energy industry as well as in the academy. For the next 18 minutes, Francois will introduce you to a novel electric vehicle concept that is poised to be a potential industry disruptor. At the end of the presentation, we shall field questions from you, the members of the audience, and please use the private chat function in Zoom to submit your questions at any point during or after the presentation. So Francois, welcome to Forum 2100. You are now addressing an interested audience that spans about 12 distinct time zones. The floor is yours.
Thank you, David. Hello, everybody. Hope you can all hear me well. I'm Francois Vuille, chairman of Softcar. And today I'd like to introduce you to this new concept. And as you can see on the first slide, we actually strongly believe that we're able to produce the lowest cost and the cleanest car ever. So at this very moment, I guess that most of you probably think we're a bunch of nuts, which is fine. I can live with that. I need to move on the next slide, thank you. So this is the three nut people that are the founder of this company, created in 2011. Now I have about 17 minutes left, I think, to prove you that what we offer and what we've developed is actually quite sound and very realistic. I need first to tell you a little bit about the history of Softcar so that you understand the background and where we come from. That's actually not something new. It all started in the early 90s with the Swatch mobile concept that was developed by the Swatch group. And you see here Nick Hayek, the former CEO of the Swatch group, which decided to to create a completely new concept of vehicles, heavily plastic-based, electrified, which was really ahead of its time. Unfortunately, the concept was then bought in, and you can see here on the upper left, that the Swatch mobile concept became actually the smart vehicle, and the OEM industry actually removed pretty much all the innovation that was introduced by the Swatch group. So all the electrified drivetrain was removed, all the plastic body parts were removed. So it made the engineers behind the project relatively frustrated at that time, and they decided to go their own route and created, and you see here, the Cray vehicle, which actually was produced in Switzerland. At that time, Switzerland was one of the largest producers of electric vehicles in the world, probably just behind General Motors. Except that General Motors, they crashed all their vehicles. The one that you see on the screen are actually still up and running some 17 or 18 years later throughout the world. We sold a couple of hundreds, and they're still doing absolutely fine. We were unfortunately ahead of our time. Battery technology was not time to say hello to our Chinese friends that have joined the call. I know you're quite a few around. But the turning point for us was our partnership with the group Total, a large petrochemical company, who wanted to understand whether there was possible to use biopolymers to actually make create plastic parts, a plastic body for a car. So we entered in partnership with Total, and they supplied us with a couple of 100 kilos of biopolymer in powder. And 6 months later, we delivered 3 prototypes, running prototypes, back to Total, which were showed in many roadshow around the world, quite successful. And it was the first ever bioplastic car produced. It enabled us to test the technology regarding safety aspects, and we had an extensive crash test campaigns on some parts of the car to demonstrate that actually we were beyond expectation regarding crash capabilities. Then we created a vehicle in 2015 because we needed to test our in situ, our technologies. And this we had this racing car that we developed in-house as well. And that enables us to relatively quickly transfer technology that we develop in our labs onto rolling vehicles that can be tested on circuits. Our next step is to integrate all the technologies that we've developed over the years, starting back with what Swatch did in 1995, and have the, sorry, that's the racing car, and this is a soft car that we plan to assemble, to finalize in 2018, and ideally to go into production starting off next year. So that's it for the history of the project. A little word on technology. How do we make the soft car? Basically, we take the same approach that you hear on the left that Swatch used to produce the lowest cost watch in Switzerland, which is still probably the most expensive country in the world to manufacture pretty much anything. And we still manage, thanks to a completely novel breakthrough approach to watch manufacturing that consisted in using new materials to be able to reduce the number of parts. Here for the Swatch was 90 or roughly 90 parts down to 50. Basically, we do the same on the soft car. We started from scratch and we thought, okay, we redesign a car from scratch using advanced materials and biopolymer materials and really recreating the complete architecture on the vehicle. And we realized by doing that, you can actually reduce significant number of parts. And here in the classic electric vehicles, you have roughly 40 parts, every component's counted, right? In a soft car, we have 1,800. So we have factor 20 down in the number of parts. And as I'll show you later, this has obviously very important impact in terms of simplification of manufacturing and cost. So for instance, if you take the entire body of the vehicle, the body of the vehicle is made of 5 large single material parts. If you compare that to classical manufacturing in a steel-based car, that's probably about 3,500 parts. We are down to 5. If you take a seat, that's pretty much only 4 parts. So everything is reduced significantly. That's the basic concept. But you can only do that if you redesign the car from scratch. You cannot start from a steel-based chassis classical framework, because there you're bound to the given structure, and you can only replace parts by parts. Here, by redesigning from scratch, we enable a completely new architecture to emerge. We also based on what's called eco-design. I guess most of you are familiar with that. The idea is to try and reduce the environmental impact as far as possible. So all of our material on the top left are biosourced. They come from biomass products. Our car at the moment is beetroot based. Then we have extremely clean manufacturing, because the molding process that we use, when the parts come out of the mold, they are already finished. We don't need any surface treatment. We don't need any heavy, dirty bath of many kind that is used in classical manufacturing, automotive. Here we are very lean in our manufacturing. The use is very efficient because by using advanced materials and biopolymer, we actually reduce significantly the weight of the vehicle. This car weighs only 400 kilos. So that's about 3 times less than an equivalent classical electric vehicle. Even 4 or 5 times less compared to the heaviest one of comparable size. And then the final step on the bottom left, by actually making sure that our design is made of large parts that are single material, is the recycling. significantly. We can be manually disassembled, and all the parts can be sent back to the mold for reuse. And we estimate that you can use the materials up to 10 times to make 10 different vehicles. So that's for the technology behind it. What's that for the customer? I mean, how does it differ from classical vehicle? Well, I have a little movie here that is the body swap concept. The nice thing about Softcar, it's mainly made of manual assembly. And if you take the body, the entire body can be removed and changed within roughly half an hour. So that's actually gives, let me play it again, it's so fun to watch. So you go back to your garage, they store a different body for you. So either you had a little scratch or an accident or whatever, or you just simply want actually to change color. And actually we can offer for the customer to own the chassis, which is disconnected from the body. So you can actually buy the chassis and then have an a la carte body swap concept where you can change not only the color, but maybe also the design of your vehicle depending on the season. So you have your Chevrolet in winter that comes into an open deck. How do you call that? The cabriolet in the summertime, right? And you can change according to the season for minimal cost because it takes only half hour of labor to change the entire body, which is something you obviously cannot do at all with a classical steel-based chassis. In terms of business model, how does it? Because very often when you talk about eco-design, comes at a cost. So here, just to remind you, we have a sustainable material that you use bioplastic and advanced composite. We have a disruptive architecture, reduced number of parts, very low weight, which means we have a comparatively low battery pack for the same autonomy. Large single material parts, all right, so that's very important for the manufacturing. In terms of manufacturing, it's very lean, no surface painting, no treatment, no robots, mainly manual assembly. So how does it translate in economic value? Well, the nice thing is that thanks to the eco-design, normally eco-design in classical manufacturing comes at an additional cost. Here it is because, or thanks to the fact that we are eco-design, we actually significantly lower production cost. Our estimate, and it's based on what we did already with the production of the Cray 10 years ago, we can produce the vehicle. The production cost in Switzerland is estimated to be around $8,000, including batteries, if produced in Switzerland, which again is probably not the best country you want to produce car in. The other very big advantage, so that's an advantage for the customer, but in terms of investment, we are actually very low capital intensive because we can produce small series that are defined, the manufacturing line is defined by the capability of the molding tools. So with one set of molds, which cost about, the plants for manufacturing would cost about 20 million, you can produce 8,000 cars and still retain economic value. So that's extraordinarily interesting because if you compare that to classical manufacturing of cars, you basically need to invest $2 to $3 billion in manufacturing lines, which are mostly very heavily automated. And you need then to break even, produce 150 to 200,000 cars per year, retaining very low margin. Here we can grow organically. We can produce one manufacturing line, pay 20 million, which is very small, push the production up to capacity, 8,000 cars a year. If the market takes up, well, you put a second line next to it, and then a third line. And then the fourth line can be maybe in a different city, with a different design, where each city, large city or region in the world can have their own design, own color, where people can identify to the vehicle that belongs to their city only. We estimate our break-even always depends on the sales price, but we can have a break-even below 5,000 vehicles per year, which is extraordinarily low. And obviously, this also is a very good model for licensing. That's a very, this agility of the economics makes licensing very, very nice, or franchising. And you can have different cities actually ordering you new designs and producing just for their city. And we already have many cities around the world that are interested to produce their own vehicles, as well as fleet owners, because very often fleet owners want to have specific design, and the automotive industry is normally not able to make much changes to existing designs for small series. Here we can respond to the needs, the specific needs of fleet owners, such as, you know, handicapped people type vehicle, where we can design the car specifically for a category of users, while keeping the production cost very low. And last but not least, the last box here, we bring local qualified job, which is normally well perceived by local governments, because you avoid having giga factories, but in small factories close to where the business is. Then that's how we are, so that we have a licensing approach, but we still, the idea is to have cloud manufacturing approach, where we have 4 modules that we pre-assemble in different factories, and then we send them to assembly lines that have licenses in different countries or different regions throughout the world. So that's the different interests that we already have around this project. You can see we have Kazakhstan here, lots of interest in Europe, Middle East, China. We also have a lot of contacts, so it's doing quite well. There is definitely traction for this new way of manufacturing vehicles. At the moment, we do have a financing rounds open. So at the top here, you see the early development that we did. Same team there from the beginning. The different vehicles that we started, that was before the time of Softcar being created. Then from Softcar time 2011 to 2018, second line, we produced the Total car for the Total group, demonstrating the technology, demonstrating we could produce car using bioplastic and advanced composite materials. We produced the Aventor vehicle, and now we are ready to start our pre-series, and first, using the exact same manufacturing tool that we use for the pre-series, we are planning to go in production. The idea is to have the first manufacturing line in Switzerland, small capacity, but if we can do it in Switzerland, and if we can produce the lowest cost and the lowest cost and the cleanest car in Switzerland, then we will not need much due diligence work to reproduce or sell licensing throughout the world, which is our next step at the bottom of this slide. The cost that we need to do that in Switzerland, we're looking at the moment for an amount roughly of 12 million, could be between maybe a little bit more if we want to subcontract a little less, if we want to do everything in-house. Our idea here is to have the first manufacturing plant with subcontracting as much as we can to lower the capex and lower the risk for the investors. So we have already a lineup of investors interested from Switzerland, from Middle East, from China, from Canada, and any of you with a spare million in the back pocket, please do contact me. I think I have my email on the next slide, and if you want to have more information on that, you're more than welcome. And then obviously we'll help. I mean, the licensing will be us providing turnkey plants everywhere in the world. That's that's the business we want to do. Softcar, we don't intend to manufacture and sell cars ourselves beyond the pilot line in Switzerland. It's really a licensing approach. We want to rely on partners throughout the world that have access to the market. So I think that's about it. I think we have a saying in Switzerland, you know, Swiss people always tend to be on time. That's actually wrong. The real saying in Switzerland, we say, if you're on time, you're already late. So here, I think I have 50 seconds left, which I'll leave open for the additional questions. Excellent. Thank you very much to all of you for attending.
Very Swiss. Francois, thank you very much. Very interesting presentation. There are a number of questions that have come in. Let me begin with the with one that goes right to something that I've heard from a couple of people. Can you please say a little bit more about the expected safety performance? Softcar will be a very small, a very light vehicle on the road, sharing the road with big, heavy trucks that are made from steel. Would you compare the safety performance or the expected safety performance of Softcar with that of, say, a more standard vehicle like a traditional Volvo estate car?
Yeah, thanks for the question. I was obviously expecting it. So first thing you should understand is a classical car chassis-based, steel-based chassis car is absorbing energy from shocks by the mass crushing the metal, basically. What we do here using bioplastic is we absorb the shocks a lot by elastic deformation. So, and the idea of the reason why Total asked us to go in partnership with them was the main reason why, to demonstrate that we're able to produce a car based on plastic that would respond to very high safety standard. So at first we didn't know, and we tested. We did the crash test campaigns. At the moment we didn't crash full cars, because it's when you're a young company, it's a bit too expensive a process. So but we crashed parts, and we did that quite systematically. And the result of the crash test was beyond expectations. We can absorb much more in an elastic way, and it's quite impressive. I can't show you now with movies, but it's quite impressive to see how the cars can absorb the shock. And obviously then you have clever design where you absorb the shock from the body for low speed crash, and the high speed crash are still taken back by the chassis, transferring the energy from the front to the back, or depending on the size of the crash. But short answer, yes, we know we can reach very high safety standards. Now, obviously you shouldn't compare a vehicle, a city car, urban car with a truck. Right, you need to compare, but in equivalent category, we expect we could actually set a new safety standard.
Okay, well, this maybe opens another line of questioning, which is how the vehicle would be used. Given that it's going to be very small, how would you expect it to be used in comparison, let's say, to other vehicles, possibly within its own size category, like a Fiat 500? Or maybe when it's sharing the road with another electric vehicle like a Tesla? Is there some specific way that you think that or ways that you think that the software would be used?
So first I should say that we are very flexible in terms of design. We have a chassis which is disconnected from the body part. So you can, in terms of design size of the car, the size of the car is defined by the size of the chassis, and we can very easily extend or widen the chassis base to have a bigger car. And then you put a polymer body on top, which also has an infinite design possibilities, actually much more than what you can do with steel. So we're not bound to the design that you see on these slides, which is the type of car which we will go first on the market with, because we think that's the most interesting market segments. But we have an infinite possibility to change design. And what we think is we want to start with an urban car, which is low cost, but which still that's a four-seater. The Softcar, as you see it here, is a four-seater, equivalent size to an EMF or a Volkswagen Golf type size. So it's a classical city car. But we could also do, we have a small battery pack. We are very efficient, so we can increase the battery pack, increase the range, and have vehicles that are able to have much longer distances traveled. The idea is not to go for a fancy car. It will still be plastic based, and we want to market it as a fun car. We're not trying to replicate, to copy what steel based shiny car are doing. That's not our goal, and I think we would lose the game if we do that. We want to sell it and to market it as a fine vehicle. We can make it transparent using biopolymer. We can make it a transparent car. We can do a retro illumination where you basically have the car change color depending on whether it's accelerating or decelerating, braking. That's which fantastic opportunities. We want to use the opportunity of having plastic to make it fun.
Okay, so here's another question that has come up relating to the composite material, the biopolymer. The use of the beetroot as the source of the polymer is very intriguing. So why would you choose beetroot? I guess that's number one. And then the second question is, could use of large quantities of beetroot run into concerns similar to the fuel versus food trade-off, or the total life cycle of emissions arguments that are associated with biofuels?
Yeah. So first part of the question, we're using beetroot at the moment because Total is producing this biopolymer material using beetroot, and that's what they're supplying us with. But we could use different biomass type to produce the same plastics. That's not an issue. Now, we are not at all in a fuel versus food paradigm, because we're not burning the plastic. If you put biofuel, biodiesel, and bioethanol in your tank, you burn it in your engine. We're not doing that. We're producing plastic, which we're going to reuse, recycle, reuse. So we're not using the amount of material that we use is significantly less, orders of magnitude less than if you're simply burning the fuel.
So here's one that's come up. The question is, have you considered the possibility that auto dealers might also manufacture these, thus eliminating the middle manufacturer?
Auto dealers, yeah. Well, why not? Auto dealers could, for sure, maybe not manufacture everything, but they could change the job of auto dealers. Certainly, they would be able to remove the bodies and change the body swap concept can be done by auto dealers. But they could, to some extent, also do the assembly line themselves, because that's relatively easy and it's all manual assembly. So we are offering new jobs for auto dealers. That's quite possible. Yes, indeed. Yeah.
Okay, there are 2 or 3 questions here that relate to performance. So let's see, the overall performance of Softcar. You've indicated that the range is up to about 300 kilometers, if I'm not mistaken. Presumably, the acceleration from 0 to 100 kilometers per hour is reasonably fast, given the size of the vehicle. What about other aspects of performance? So for example, what sort of battery recharging time are you estimating for software? Are there any performance concessions that customers would need to accept?
So we are I mean, the technology of the battery and the recharging and the motors, we're not developing motors and drivetrains. Our IP is in the architecture of the vehicle. So we're buying batteries from off the shelf. So the recharging time of each cell will depend on the type of battery. Now, given we are very light, at equivalent autonomy or range, we have a much smaller battery packs, like about 2.5 times smaller than equivalent performance electric vehicles available commercially. So a smaller battery pack means we will be twice as fast to recharge at equivalent range. The other thing, the nice thing about being light is you don't need assistance to driving or assistance to braking. So you have a much direct control of your car. And we had a lot of professional Formula One pilots testing our vehicles, and they said it's fantastic to drive because you feel the road a little bit like when you're on a kart car or even a bicycle. You're very close to the sensation, the feel is much different. Any intention to have a model of Softcar such that it would be equipped with self-driving, the autonomous vehicle capabilities? Yeah, so we design it so that it's compatible with self-driving cars. Yes, I mean the idea, and given we're very light, we can do a lot of very fancy things. A lot of companies that want to have self-driving fleets are contacting us because they're very interested. We have a much cheaper or lower cost option to have fleets of autonomous cars. Yes. Okay. A question that's big in the industry right now, particularly relating to electric vehicles, focuses on Tesla's experience in terms of its production. It's fallen way behind its targets for manufacturing for the Model 3. Would you expect similar sort of initial challenges in bringing Softcar to scale? Initial challenges, yes, certainly, like in any disruptive project. But with the latest manufacturing techniques that we use for rotomolding, for producing the body of the car, we don't actually expect a significant challenge that we are, hurdles that we will be showstopper? Absolutely not. And here we are hand in hand with Total, so we're mastering the process, I think.
Okay, Francois, thank you very much. This brings us to the formal close of our online session. We shall post the recording of the session on our website. That's www.forum2100.org. In the event that you would like to review it, along with Francois's contact information. As we are actively building the audience around the globe, please do pass the information on the Business and Energy Talks to anyone else you think might be interested. So please join us for our next talk in the series, which will take place on the 16th of May. That's another Wednesday at 11:30 a.m. Eastern Daylight Time. That's 4:30 p.m. GMT. Our presenter will be Ana De Meo, speaking on motivations for widespread adoption of smart microgrids. You can find a brief biographical profile of Ana on the website. And if you or a colleague have an idea for a talk, please don't hesitate to visit the website, submit a proposal to us. We'd love to take a look at it to consider it to be included in the series. Dave Nagel and I wish you all very well, and we look forward to welcoming you and your colleagues to Ana's talk on Wednesday, the 16th of May. Thanks for joining us today, and bye for now.